lovely one, it's me, Helen the Great, and you are busy preparing for your grade 11 exams. So we're going to start with some paper 1 content today, and we are solving for x. Now remember that whenever you're solving for x, they're probably testing you on factorization as well as exponents, and how do you work with fractions and all sorts of things like that. And as you can see, we've got all of those represented. We also have a simultaneous equation that goes to the other side of the screen, but we'll get there. So let's start with question A. We've got x squared is equals to 4x. Now, because it is a quadratic equation, and I know that because of the squared, squared, quad, yes. Because it is a quadratic equation, I'm going to make it equal to 0. And then I'm going to factorize it by taking out a common factor of x. So that leaves me now with x times by x minus 4 is equals to 0. Now, the whole theory behind quadratic equations is that anything that is multiplied by 0 is going to equal 0. And that's why we divide the two factors up into x and make that equal to 0, and x minus 4 and make that equal to 0. And we solve for both. Obviously x is equals to 0 is as far as we can go, and then x is equals to 4 is the other one. The reason why this would work is because if x was 4, 4 minus 4 would be 0. 0 times by x would give us 0. So that's how that works, and you should feel very comfortable with that after grade 10. And now we move a little bit down so that we have some space to do the next one. We've got a fraction. We've got x plus 3 over 2 is equals to negative 3 over x minus 2. Because it's a fraction, I'm going to find a lowest common denominator. If I have a lowest common denominator on both sides, if I've changed the denominators on both sides, I can do something magical. And the magical thing is actually just dropping the denominators. So originally, I had a fraction of x plus 3 over 2. Now I'm going to multiply both the bottom and the top by x minus 2 to get to my LCD of 2 into brackets x minus 2. So on the other side, I've got minus 3 over x minus 2. That's the original fraction, but now I need to make it 2, x minus 2, so I'm going to multiply both the top and the bottom by 2. Because our denominators are on the same, or are the same value on both sides of the equal sign, we can just drop them. And now we have x plus 3 into brackets x minus 2 is equals to, well, let's just multiply that out because it's nice and easy, negative 6. So now we have x squared minus 2x plus 3x minus 6 is equals to minus 6. And because it's a quadratic equation, we can make it all equal to 0. So we have x squared minus 2x plus 3x is going to be x. And I've got the minus 6, and I'm also bringing the other 6 over, so it's plus 6. And that gives us a beautiful equation of x squared plus x is equals to 0. We still need to factorize it, so let's go down a little. And we always start by looking for a common factor. In this case, our common factor is quite easy to spot. We've got x as a common factor in both. If we take out x as a common factor, x squared would become x, and x divided by x becomes 1. Now, as we said before, anything multiplied by 0 has a value of 0, and that's why we divide the two factors, in other words, the x and the x plus 1, into two different equations. So x plus 1 is equals to 0. That means x is going to be equal to negative 1. Our two answers then are x is equals to 0 and x is equals to negative 1. Let's move on up and go and see the next question. And a lovely exponential equation. Now the trick is to change everything to products of their prime factors first. So we know 2 is 2. Let's put it like that. But then we have 8 is actually 2 to the power of 3. And then that's to the power of x. At the bottom, 4 is actually 2 to the power of 2x minus 1. I'm going to put that in brackets now. And then 32 is actually 2 to the power of 5, isn't it? So now we have something we can work with. I'm going to change 2 to the power of x minus 4 into 2 to the power of x times by 2 to the power of negative 4. And it'll become more obvious just now why I'm doing that. In the meantime, I'm multiplying things out. So it becomes 2 to the power of 2x. And don't forget to multiply the negative 1 by 2 as well. And then we've got 2 to the power of 5 on the other side. I'm also going to break this up a bit and add these and see what happens. So I have 2 to the power of 2x, or 4x at least, at the top, times by 2 to the power of negative 4. And at the bottom, I have 2 to the power of 2x times by 2 to the power of negative 2 is equals to 2 to the power of 5. Now I'm going to fiddle with it a bit. I'm going to do some cancelling and all sorts of stuff like that. I'm actually just going to bring things to the top. So let's do that. 2 to the power of 4x minus 2x, why? Because that comes to the top and then we subtract it. Then we've got 2 to the power of negative 4. We're bringing this to the top. It was negative 2, it now becomes plus 2, is equals to 2 to the power of 5, and I know I'm running out of space here, so let's just do it over here, and we'll shift over just now. So now I have 2 to the power of 2x times by 2 to the power of negative 2 is equals to 2 to the power of 5. So we can change this now to be something nicer to look at. Is equals to 2 to the power of 5. And because we are logical and clever people, we know that if this side is equals to that side, and this value is the same as that value, then automatically 2x minus 2 is the same as 5. So now 2x minus 2 is equals to 5, and we can solve for x. That becomes 5 plus 2 is 7, x is equals to 7 over 2. It's not bad at all. Okay, and let's scroll down a little to see what's happening over here. Now this is a favorite question to do in exams because it looks rubbish. It really looks like something that will make people cry. But when we start breaking it down, it's actually not that bad. If we think about it, 5 to the power of 2015 is the same as 5, oopsie, let's just cross that out, is the same as 5 to the power of 2014 times by 5 to the power of 1. And the reason why that is, I don't know why I'm doing 2's. Here we go, a 5 to the power of 2014. The reason why that's useful is because now we can take out a common factor, can't we? Much nicer. But let's do the denominator as well. So I've got 5 to the power of 2015. I'm going to change it to 5 to the power of 2014 times by 5 to the power of 1 minus 5 to the power of 2014. So once again, a common factor, 5 to the power of 2014 and 5 to the power of 2014. Let's take it out. So at the top, 5 to the power of 2014. We're left with 5 plus 1. Looks much easier now, doesn't it? Take out 5 to the power of 2014 at the bottom. And you can see how beautifully this is going to cancel. Now we've got 5 minus 1 at the bottom. we cancel and we cancel, which leaves us with what's 5 plus 1, that's 6, and 5 minus 1 is 4, so that means our answer, simplified answer, is going to be 3 over 2. So x is equals to 3 over 2. It looks terrible, but it really isn't. Okay, so now I'm moving over for the simultaneous equations. I'm also going to change color just so that it's obvious to see where we're going. We've got x squared minus y squared is equals to 24, and x minus y is equals to 2. I'm going to start by changing this so that x is the subject of the formula. And I'll name this one 1. And I'll name this one 2. And I name them just so that I can tell the marker what I'm doing. I'm going to substitute equation 1 into equation 2. So that means everywhere where I see an x, I am going to replace it with 2 plus y. So I've got 2 plus y squared, and that's in place of the x, minus y squared is equals to 24. Let's square a binomial, so that's going to be 4 plus 4y plus y squared minus y squared is equals to 24, and that is beautiful because y squared minus y squared is 0. So now I have 4 plus 4y is equals to 24. 4y is equals to 24 minus 4, and let's just scroll down. So I've got y is equals to 20 divided by 4, which is 5. Now be careful here, this is where many people will stop. And the problem is we need to solve for both x and y. So we do need to go back, use the y that we have, and figure out what x is. And this is where it gets really easy. We have the value of y. We can substitute it in. Remember, you're telling the marker what you're doing. We can substitute it into whatever equation we like. So we could either choose equation 2, or we could choose equation 1, and I'm sure you agree with me that equation 1 is far easier. So x is equals to 2 plus 5, which means it's equals to 7. So therefore, my final answer is y is equals to 5, and x is equals to 7. If this were a problem on the Cartesian plane, which it's not, you would write your final answer as 7, 5, because that's the coordinate. But it's not, it's just a straightforward solve for x and y simultaneously. Well, my lovely one, that is a whole question 1 of paper 1. It is worth 20 marks. So it's 20 easy marks. All you've got to do is make sure you can work with algebra. Much love.
Mm.